In this problem, we're looking at two functions. We're looking at one that gives us the between 2000 and 2009 the number of arrests T years after 2000 that were due to possession of heroin and cocaine, and then we have a model that gives the number of agencies that contributed to these arrests is C of T equals, and then there's our function, which is in millions of agencies. So we want to find a function, write a function. This is not a derivative. This is just a basic output function, R of t, that gives the average number of arrests made per agency. So what we want is we want a function who outputs arrests per agency. Now we have two functions. One outputs millions of arrests, and a second one, C, which outputs millions of agencies. So we can pretty clearly see that if we take this and we divide by this guy here, then we'll have millions of agencies, or millions of arrests per million agencies. And just like it doesn't matter if you say, you know, one pound of apples is $1 or 100 pounds of apples is $100, the millions don't need to be there since they're the same quantitative unit. So the millions cancel out and we have arrests per agency, or you can just say millions of agency. And so R of t would just be the ratio of A of t and C of t. So there's our function that we need. Well, in part B, we're going to need to find the derivative. So because we have a quotient, we're going to use the quotient rule, which, remember, I'll just write the kind of the quick and dirty off to the side here, assuming that we know why we're applying this, because we have a quotient, we need to find its derivative. So R prime of t will require us to put these pieces together. So that means we need to find the derivative of f. So f prime is a cubic function, which is the derivative of a, actually. So that's going to be negative 0.15 t squared plus 1.1 t minus 1.91. G prime is going to be the derivative of this guy, which is negative 0.16 t plus 0.69, and then the constant goes away since derivative of a constant is 0. So now I'm going to put these all together. I'm going to say, I'm going to try to fit it all, squeeze it all down here so I don't have to keep referencing this page. But f prime, so my derivative of r is f prime, which is negative 0.15 t squared plus 1.1 t minus 1.91 times g, which is the original denominator, which is negative 0.08 t squared plus 0.69 t plus 9.09 minus fg prime. Well, f is the original numerator, so we'll write negative 0.05 t cubed plus 0.55 t squared minus 1.91 t plus 12.75, and this is millions of arrests. So now we just need to multiply that by g prime, which is the derivative of our denominator. Sorry, this is kind of going on and on here, which is negative 0.16 t plus 0.69. Maybe it wasn't a good idea to write this all on one page. But anyway, it's this whole thing right here divided by, so I'll just put my fraction bar here, and this looks terrible, g squared, which is negative 0.08 t squared plus 0.69 t plus 9.09. Oh boy. And this whole thing is going to be squared. Okay, well, I'm sorry that that kind of got stuck all on one page. I started writing it, and I'll just leave it there. Well, let's work up letter B over here so I can easily reference this. That's the only problem with this, is that it's just so long. And I want to find r prime of 5. So I have my r prime right here, and now I just need to go through this mission of plugging everything in. So my recommendation is, so that you don't get too messed up with the parentheses, is just to do the numerator first, because the numerator is a lot like the product rule, except that it has a minus in between the products. So I'm going to do negative 0.15 times 5 squared plus 1.1 times 5 minus 1.91 times negative 0.08 times 5 to the third, or 5 squared, excuse me, plus 0.69 times 5 plus 9.09. And now I'm going to subtract away negative 0.05 times 5 to the third plus 0.55 times 5 squared minus 1.91 times 5 plus, let's see, what was our plus? Our plus was 12.75. And multiply that by negative 0.16, whoops, negative 0.16 times 5 plus 0.69. And that should be my entire numerator right there. So that big old mess is my entire numerator. And so I get negative 0.5094. Okay, and so now I'm going to divide that by the result of the denominator, which is just going to be negative point, oops, I need to put this in parentheses because the whole thing is going to be squared. Negative 0.08 times 5 squared plus 0.69 times 5 plus 9.09. And I get 10.54. Okay, well now I can divide these two. Negative 0.5094 divided by 10.54, and I get about 0.04, negative 0.0483. So what does that mean? Negative 0.0483. So r prime of 5 equals negative 0.0483. Well, let's think about the units. So r of t, what does that output? That outputs arrests per agency. So that itself appears to be a rate of change, but the t itself represents years. So this is in the year 2005. Oh, and so our derivative, its units would be arrests per agency per year. So in other words, what's happening to our ratio of arrests to agency? Do we expect more, each agency to have more arrests next year or fewer? Well, according to this, in 2005, the number of arrests per agency was increasing by, or excuse me, decreasing, not increasing, decreasing by 0.0483 arrests per agency per year. So in other words, regardless of what that rate, regardless of how many arrests they had per agency in that current year, it's expected to go down a little bit. And so that's our final answer, and we are done.